अरे ये पेन टैब है। इसमें इरेजर कर दिया। That is
मान लो अगर आवाज कम होती है या फिर साउंडलेस होता है तो मैं माइक लेके बोलता भी रहता है जो चीज मैं लिख रहा हूँ. नाउ दिस इज स्टैटिक पोर्शन विल क्रिएट
ये
द
रिकॉर्ड
बेंडिंग. हाँ रिकॉर्ड हो रहा है. विल क्रिएट द बेंडिंग मोमेंट.
कॉल करो.
नहीं जाने दे. कौन इतना देख ही रहा है.
नहीं, जब टाइम जा रहा था उसको बोलते थे पूरा कंप्लीट करेंगे ना.
अरे कुछ नहीं से रैंडम है पूरा अच्छे से नहीं कर रहा ना.
प्रैक्टिस चल रहा है ना.
प्रैक्टिस है ये.
ठीक है. इस वाले रूम को पूरा मतलब ब्लॉक करके चीजें देख रहे हैं.
कोई एक रूम जिसमें शांति हो उसमें कर सकते हैं ताकि एक रूम में वैसा नहीं मेरी वजह से सारे चुपचाप कबूतर की तरह बैठे हुए. नहीं
नहीं, वो जब खाली रहेगा तो ये फ्री रहेगा.
वही मतलब एक रूम रहेगा.
एंगेज रहेगा.
नाउ डब्ल्यू क्रिएट कहेगा. इसमें डिस्कशन चल रहा है. डब्ल्यू क्रिएट uplift and net upward pressure due to which bending moment will occur on one face of the footing. Understand, my dear children? Why? Okay, no problem. I will make this video for you people. You people are hungry people for footing design. No problem. So the net length. धाकड़ सर को देखा है. दवा कर लाइकन से ठोकिए महाकाल की कृपा से.
क्यों महाकाल कह रहा होता है ना. मैं तो लगता है गाली दे रहा है.
महाकाल की कृपा से इतनी बारिश नहीं हुई. ठीक है. Now bending moment WL square by 2 due to cantilever action. Now WU into L हो गया B minus B by 2 का square by 2 that is WU into B minus B का square by 8. Now WU is 1.1 P by P into D. So here you calculate 1.1 P by B into D. That will become W, and after that you will calculate the bending moment of the footing on the one side. So on behalf of that footing you have a bending moment, and this bending moment this is called MU, and due to this MU you have to create this 1.1 into 1.5 so that you can factorize this WU. That MU will become ultimate bending moment that is occur on the footing. So on behalf of that you have to calculate the ST. Then the formula of ST is, what is the formula of ST? 0.5 FCKY FY into BD 1 minus under root 1 minus 4.6 R. What is R? R is MU by FCK BD square. Now you have FCK by MU BD square. So what is B? What is D? Is this B and D is column B and D? No, footing B and D. So this B and D is capital B and this is capital D. MCK becomes BD square. Okay. So R is calculated due to which ST calculated, and due to this ST you will create a percentage PT that is 100 ST by BD. So this is PT percent. On that PT percent you have to calculate beta. So what is beta? Beta is 1.116 PT FCK by PT. So this beta will be greater than 1, and due to this beta you have to create tau C. Tau C is what? 0.8 into under root 0.85 FCK into under root 5 beta plus 1 minus 1 upon 6 beta. So this will create a tau C SP16, then tau C. And now you have to calculate VU. What is VU? WU B minus B by 2. This VU, and due to this VU, you have to calculate tau V, that VU by BD. This tau V is greater than tau C, what we calculate over here. So, no, sorry, this tau C will greater than tau V, so that shear, no need of shear and force, it means it will be pass in shear. It will pass in shear. Otherwise, you have to increase the steel, percentage PT or depth. Okay, so it will decrease tau shear, because how can I say this? Now you have to understood that VU is inversely proportional to D. If you increase D, VU will decrease. Now tau C is proportional to 1 upon under root beta. If you increase beta, then tau C will decrease. So if you want to decrease beta, then beta is dependent on 0.16 FCK by PT. So it is 0.116 FCK by PT. Either you increase PT or you decrease FCK. So it will decrease the beta value. Okay. So this is the total gist of this footing design, that how can you calculate the footing design, and this parameter will very helpful to you, very helpful parameter to decide the footing size and depth. Okay, so this is one way here. Actually, I just calculate this is your footing. This is your footing. So in this footing, I just calculate one side of this footing. I just calculate only one side of bending moment. This is used for bending moment, and from D distance, D for depth. So this is the depth. This footing depth, something like that. So this is the depth. So this distance will cover shear force, and D by 2 distance. This is D by 2 distance, and for D by 2 distance, 2 is here. This means if this is B, this is D, then it will become B plus D by 2 plus D by 2, and this will become D plus D by 2 plus D by 2. This is not a depth, this is the width of column. So this is D dash plus 2D, 2D by 2, that is D dash plus D. So for 2S here, 2S here, the load act from top should be balanced from the shearing action of this surface which is held in the depth. So what I want to say, P load, what is shear force formula? Load by area. So what is load coming from the footing, that is P, not footing from column P, that is divided between the area, that is B plus D into D dash plus D. So this is the tau V. Now tau V, this tau V is two-way shear footing tau V. This should be less than tau C max. This should be less than tau C max, and this is 0.16 L root FCK WSM, 0.25 FCK under root FCK LSM. So this will be tau C max, and if it is less than tau C, then again good, again good. This is tau V, but this tau V is not a punching shear. Actually, this is load coming. Who is going to punch this footing? So who is counterbalance action of this this footing? So if I draw a diagram, that is this is a 3D diagram to make you understand that I'm not madman. So this is this should be placed in such okay. So this should be jointed over here. So this is jointed over here. This load is coming over here. This is D depth. This length is D dash plus 2D by 2. It means D dash plus D. And this length is B plus D. Now what I want to say, what is the perimeter of this surface? This surface, and similarly the back surface and the front surface. It will resist the shearing action which is coming from the top of the column. So what is the total perimetric area of this footing which is going to resist the shear action of the load? So the perimeter is D dash plus D into B plus D into capital D. That is the perimetric area. So okay, but it will become a volume. No, I have just to calculate. So plus 2 times, that is the perimeter, and that is D, that is the total surface area of this something what I want. Yeah, this section. Okay, so this section will resist. So and this section have some shear value, that is tau C value. So this tau C into 2 times D dash plus D plus B plus D into D should be equal to 1.1 P upon B plus D into D dash plus D. So due to that, you have to calculate tau C value. Okay. Thank you.